Have you ever performed a database query, then run the exact same query again within the same transaction, only to see new rows magically appear or previously seen rows vanish? It can certainly feel like data is playing tricks on you. The root cause of phantom reads is an insufficient database transaction isolation level that allows new rows to be inserted or existing rows to be deleted by another concurrent transaction between two identical read operations within the same logical transaction. To understand why this happens, we need to look at how databases manage concurrency. Transaction isolation levels dictate how and when changes made by one transaction become visible to others. Lower isolation levels, like read uncommitted and read committed, are designed for speed but offer less protection against concurrency issues. The repeatable read isolation level, which is a step up, guarantees that any row a transaction has already read will not change if read again. However, it typically achieves this by placing locks only on the specific rows that have been accessed. The crucial point is that repeatable read usually does not place a lock on the entire asterisk range of possible rows that a query might return. So, if your transaction reads all users from a specific city, and another transaction then inserts a brand new user into that very same city, a subsequent identical read by your transaction will suddenly see this new, previously non-existent row. This new row is the phantom. Similarly, if a row was deleted that your transaction had not yet seen, it could disappear between your reads. The database allowed changes to the asterisk set of rows matching the query's criteria, not just the rows already in your transaction's read set. To prevent phantom reads, the solution is to use a higher isolation level, specifically serializable. The serializable isolation level ensures that no other transactions can modify data in a way that would change the result of a query if that query were rerun. It achieves this by employing techniques like range locks or predicate locks, which protect not just the individual rows but the entire set of rows that satisfy a query's conditions. This effectively means that once you query for a set of data, that set remains stable for the duration of your transaction. While serializable isolation offers the highest degree of data consistency, it does come with a performance trade-off. Because it places more extensive locks, it can reduce concurrency and potentially lead to more deadlocks. Many modern database systems also utilize multi-version concurrency control, often abbreviated as MVCC, to provide different versions of data to concurrent transactions, minimizing the need for physical locks during reads. Even with MVCC, the underlying principles of isolation levels and preventing phantom reads through consistent data snapshots remains fundamental. Ultimately, phantom reads highlight the delicate balance between data consistency and concurrency performance in database systems. Understanding their root cause in insufficient range protection and knowing that serializable isolation is the definitive prevention method allows you to make informed decisions about transaction management, ensuring the integrity and reliability of your data operations.
If this helps you code smarter, like, subscribe, and stay tuned for more.